Hello everyone, I'm Won-Lee. I started to explain probability distribution function yesterday. Yesterday I introduced Bernoulli distribution, Bernoulli random variable. Okay, I'm going to explain binomial distribution. Let's see what binomial distribution is. Here, Bernoulli trial repeated independently n times. Then the distribution of the result follow a binomial distribution. Especially probability x follows a Bernoulli distribution. Let x1, x2, xn be referred to as first Bernoulli trial, second Bernoulli, nth Bernoulli trial, respectively. Let's think about flipping a coin, tossing a coin. The result ht. When you get h head, then x takes 1. Okay, when you get tail, no head, so x is number of head, of course, x takes 0. That is typical Bernoulli trial. So let us flip a coin 10 times independently, 10 times, for example. Okay, then you will get x1 first result, x2 up to x10. x1, x2, x10 are independent and identical. I mean, x1 is Bernoulli, x2 Bernoulli, x10 Bernoulli. See here, xi takes 1 if success, if head. Xi takes 1. If failure, tail, then x takes 0. Okay, like this. If xi equal to 1, xi equal to 1 means what? Head. Probability of a head is 1/2. In this example, here, generally, let small p. Then sum of xi's, this one, sum of xi's has a binomial distribution. You get it? Okay, let's see here. x1 takes 1 over 0, x2 takes 1 over 0, x10 takes 1 over 0, right? Each one Bernoulli. So sum of xi's means what? When xi takes 1, add up. So x sum of xi, I from 1 to 10 is number of heads out of 10 times. X will have a binomial distribution. Okay, here. The probability distribution function for random variable, binomial random variable, is like this. This is n combination x, n combination x. Okay, what is a combination? Take x many out of n. How many ways to take x out of n? N combination divided by x, factorial. You don't have to know factorial or combination here, but you don't have to. If you see this one first time, then you don't have to worry about that. Anyway, x will take 0, 1, 2, up to n. Okay? Mean and the variance are respectively like this. What was the Bernoulli random variable x expectation? Expectation of Bernoulli was p yesterday. Variance of x was p times 1 minus p yesterday. Okay? So here, np, binomial case, expectation is np, n times p. Variance is n times Bernoulli variance, n times p times 1 minus p. Okay? Okay, let's go. In this way, I will repeat again. Binomial distribution is derived from Bernoulli distribution. That is, binomial distribution describes the distribution of a number of successes. Let it be x when Bernoulli trial is repeated independently n times. Okay? For example, there are 10 multiple choice questions with 4 options each. unfortunately, a person who cannot solve any of these problems, so just guess randomly one of 4 options, then the probability of answering correctly is what? 1 over 4. 1 over 4, right? If let the random variable x represent the number of correct answers among the 10 questions, then x follows a binomial distribution. Especially, we denote xi as the Bernoulli random variable for i's question. There are 10 questions, x1, x2, x10. In this case, xi equal to 1. The probability of xi equal to 1 is 1, 4, right? So what? X follows a binomial distribution. So if you remember n combination x, p power x 1 minus p n minus x binomial formula, then you just insert input n and x. Then you can solve that kind of problem. Let's see. For example, probability that x is 6, x6 can be calculated. X6. How many problems? 10 problems. So x I equal to 1, correct answer, then 14.25 times what? 6 power, 1 minus 0.25.75 powers 4. You can calculate this one, then you get the answer of this question. So binomial is famous for you, I think, when you study probability in high school level. But actually, Bernoulli distribution is basis of a binomial, and the Bernoulli is more important to understand proportion, ratio thing. Okay, so you better understand. You better know Bernoulli distribution, what the Bernoulli distribution is. Okay, that's it today. Thank you. Bye.